Okay, friends, let's see if I can get the right screen up here. And I've already did this video once because I've had no sleep, hardly. Obviously, I wasn't recording. So we're going to talk a little bit about air masses and fronts. You should have talked about air masses today well, maybe not talked about it, but worked on air masses today in class. With air masses, you should have learned there's a maritime tropical, maritime polar, continental tropical, continental polar. One of the key things to this, anytime you see maritime, that means water, tropical warm, polar cold, continental means land. Okay, so with a maritime tropical air mass, you have warm, humid air masses from the oceans near the tropics. It's like near the equator. They form over the Gulf of Mexico and the Atlantic Ocean. And in the summertime, they bring hot and humid weather. And in the winter, they can bring heavy snow. The maritime polar, they form over the Pacific, North Pacific, I'm sorry, I'm sleepy, North Pacific and North Atlantic Oceans. The air masses affect the west coast more than the east coast, and in the summer they bring the rain and fog and cool temperatures to the west coast. And when I think of this, I think of like Portland, and it's famous for its rain, in Seattle as well. Okay, I'm just going to do this in edit mode instead of putting in a present mode. Continental tropical, we have hot, dry air masses, and they form over the southwestern and northern Mexico. So we're talking right in here. They cover a smaller area than other air masses, and they bring hot, dry weather to the south. Continental polar, it forms over central and northern Canada and Alaska. It brings cool and cold air. In the winter, it brings cool and dry air, so we're not going to get snow from the continental polar. And in the summer, storms may occur when these polar air masses move south and they run into the tropical air masses, and that can create a storm situation. We've not learned about winds yet, but we will, probably beginning next week. The prevailing westerlies are a major wind belt in the United States. Winds get their names from where they blow from, and so prevailing westerlies push air from the west to the east. We're going to talk a little bit about fronts because we'll probably do these or learn about these on Thursday. So I thought I would just go ahead and make this recording and include them as well. When air masses meet, it's called a front. Okay? And where they meet, it can cause storms and weather changes. Again, a front may be 15 to 20 kilometers wide and extend up 10 kilometers into the troposphere. So if you remember when we were talking about the troposphere, we were talking about those very high clouds. And the kind of front depends on the characteristics of the air mass and how they move. Okay. So here we've got some symbols for fronts. We have cold fronts. Cold fronts have the little triangles, and it's usually represented in blue. Warm fronts have the semicircles, and it's in red. We have stationary fronts, And with stationary fronts, it means nothing is moving. So we have triangles on one side and the half circles on another. And then occluded fronts have cold and cold, and then they have a warm in the middle. And I'll show you a representation of what that looks like. So with cold fronts, we know that cold air is more dense than warm air. It sinks when moving a cold air mass runs slowly. Okay, let's try that again. When a moving cold air mass runs into a slowly moving warm air mass, the denser cold air slides under the warm air. All right, so what happens is, if you've got warm air here and you've got this big bad cold air coming, this thing is tough, okay, because it's so dense. So what it does is it just shoves this warm air out of the way. It just moves it and makes it go up. If there's a lot of water vapor in the warm air, then we can have some heavy rain or snow. Cold fronts move quickly, so they cause lots of weather changes. And after a cold front passes, you're going to have cool, dry air. Warm fronts, on the other hand, here we have our warm air. We have cold air in place. This warm air is kind of light. This cold air is very dense. So this warm air cannot shove this cold air out of the way. So what it does is it just kind of goes over the cold air, okay? And it's slow moving. And it's slow moving because it takes a while for it to go over the cold air. If the warm air is dry, scattered clouds can form. If it's humid, then we might have some showers and light rain. After a warm front passes, the area is likely to be warm and humid. Now, this is special right here. Everybody thinks we need a cold front in the wintertime to have snow. We don't. We need a warm front because a warm front carries the moisture, and because it's slow moving over this cold air, that would be one of those snows where we're out of school a week. So you got to think about warm fronts for snow. Stationary fronts. Stationary means something is not moving, okay? So with a stationary front, neither front has, the cold or the warm, enough force to take over the other. So they just kind of sit there and paddle it out. Where the warm and cold air meet, water vapor in the warm air turns into rain, snow, fog, or clouds. Here's a picture of the occluded front. Again, we've got cold or cool air on each side, and then you have warm air wedged in the middle. And as the warm air cools, the water vapor condenses, and the weather's going to be cloudy, rainy, or snowy. Cyclones and anticyclones. You have warm air in the center of an anticyclone or a cyclone, and it rises. And this warm air rising tends to lead to pressure being decreased because the molecules are spread further apart. Winds in a cyclone spin counterclockwise in the northern hemisphere. As the air rises in a cyclone, the air cools, forming clouds and precipitation. Winds spiral outward from the center of an anticyclone, moving towards areas of lower pressure. Winds in an anticyclone spin clockwise in the northern hemisphere. So some examples. This would be a cyclone. Hurricanes are large cyclones that cause widespread damage. And remember that most of the damage from a hurricane comes from water damage. Anticyclones. The air flows counterclockwise, like this. This is high pressure in the center, so the air tends to sink near the high pressure, and that prohibits precipitation and cloud formation. Here, we have some vocabulary. You should be familiar with most of these words: air mass, tropical, polar, maritime, continental front, occluded, cyclone, anticyclone. And then we have some review questions with answers. So, I hope this helps you understand. And if you have any questions, you can just let me know. Thank you.